In physical purity, we will look about the addition of the other seeds or the weed seeds or inert material. Under the inert material, plant debris or store or plant any other parts of the pot, broken pot pieces. So these can be included under the inert matter. So based on that, if you want to calculate the physical purity, we have to get the particular weight of the needed seed. Then among that, how much weight we able to get the pure seeds, then wheat seed, other seeds in a method like that, we can calculate for the percentage. So based on that, the physical purity can be estimated. Then moisture content also very important. I already told you, based on the storage condition and which temperature or the freezing condition we have to give, and the moisture content we have to maintain. The seeds can be divided into two, orthodox or the recalcitrant. In orthodox seeds, we can bring down the temperature even from 7 to 13% by drying. Then for the recalcitrant seed, even at the time of harvesting, if it is having 25 to 30% moisture content, immediately after extraction of the seeds, we have to plant it. If you bring down the moisture content of the seed, it will lose the viability. But for the orthodox seeds, we can bring down the moisture content to 7 to 9%, 7 to 13%. Then at the time of germination, again it can absorb the water and rehydrate it, and it can able to start the metabolic activity. So moisture content play a major role in the quality seeds, especially if you want to store it for the next time cultivation. We have to think about the moisture content. Then seed health also we have to look into. Seed health is very important because if the seed is damaged or mechanically damaged or damaged by the pest, so it will cause damage to the embryo. Due to that, it is unable to germinate. So these are the characters we have to look into in quality seed. And some benefits also we are having by using the quality seed. So we can use the less amount of seed rate, weed infestation or other infestations we can avoid in the field if we go for the multiplication, and uniform establishment of the crop we can obtain. Then due to that, maintenance of the crop also easy, harvesting easy, post-harvest operation easy, then we can get the good market price for the product. So it is response to fertilizers also very well and adapt to the climatic changes also. These are the benefits we are having by using the quality seeds. So that's the thing yesterday we have studied. Then today and also we started with the germination. Seed germination is one of the important process happening in the plant. And from the seed, it is able to give the new plant seedling. So if you use the quality seed, so the seedling quality also high. So why we should have the good quality seedling? Because if we want to produce further yield, so it is very important to have the quality seed. So the germination is a process that is happening in the angiosperm and the gymnosperm. From the viable embryo, the new plant is formed. So we are having the 5 stages in the germination process. First, the imbibition, because if we use the orthodox seeds, that means already dried seeds, so that should absorb the water. So to start their activity, it absorbs the water. That is the step we are calling rehydration. Then respiration also happening, light also needed, mobilization of the reserve that is available in the cotyledon or the endosperm is happening. And finally, due to that, the embryo is in a position to break the or rupture the seed cord, and it able to comes out. So in embryo vision, what is happening? Even after putting the seeds in the soil, what we will do, we will water it. So that case, the seed, especially dry seeds, absorb the moisture. Dry seeds absorb the moisture, and it will increase in the size. That is the step we are calling swelling happening. Then, if seeds absorb the moisture, that is the imbibition we are saying. So, if then seed coat also becoming soft. Then the other process continually happen in the seeds, and it will help to rupture the seed cord. So imbibition is the first step. So that is the step, the dried seeds. Because I already told you, if we use the recalcitrant seeds, so whether it is with the moisture content, we have to plant it. But in dry seeds, whether it is cereal or pulse or the other crop, so it has to absorb the moisture, and then it should be start the activity. So absorb the moisture, we are calling that as rehydration. Again, it is gaining the water. Because after the absorption of the water, some metabolic processes will start inside the seed. The structural and storage molecules that started to undergo metabolic activity, because it is having the enzymes. It has to go to the metabolic activity. So the respiration we are talking, because if we have the dicot seeds, it is having the scar, that is hilum. And near to the hilum, we are having the small micropyle, that is hole we are having, through which the oxygen can go inside if we put it for the germination. That case, before put it into the soil, so the respiration happen in the seed as the anaerobic respiration. Due to the glycolysis, it is getting the energy. But after put it in the soil, the oxygen can enter through the micropyle, and in aerobic respiration can start. So the oxygen begins to enter the seeds through the micropyle. In that case, we have to consider the very important thing. The plants that is suitable to grow it in the land, that plant seed, if you put it into the waterlogged condition, so that won't germinate, because that is adapted to the land, and in land we are doing the land preparation. So we are loosening the soil. Due to that, the aeration will be available to the seeds. Then the seeds which is adapted to grow it in the land, if we even provide the seeds with the waterlogged condition, it won't germinate. That is the problem. But some seeds having the ability to grow in the waterlogged condition also. So like paddy seeds, it is semi-aquatic plant. it is having the ability to grow in the waterlogged condition. So it can obtain the oxygen, needed oxygen for the germination and the energy producing respiration process through the dissolved water, because the oxygen that is available in the water in the dissolved form, that can be taken. But for the seeds adapted to the land, that can able to take the oxygen from the soil. So that case, we have to prepare the land with the fine tilled condition. So the aeration will be promoted, and that. Then if you put the seeds, that will automatically germinate. But if the seed is adapted to the land, and if you put it in the waterlogged condition, that type of seeds fail to germinate because of the insufficient oxygen availability. Then, this is the thing just from today we have to mainly look into. The light also an important factor that is determining the germination, not only for all the crops, some crops definitely need light for the germination. So, depending on the seed that is respond to the light, especially for germination, so we can commonly use the term photoblastic seeds. Seeds which is respond to the light for their germination, we can call photoblastic seeds. That also can be categorized into three: positive photoblastic, negative photoblastic, non-photoblastic. The positive photoblastic means that type of seeds do not germinate even in the darkness, because definitely it's need or it should expose to light for the germination. So that is showing the light response positively. So that it is called as positive photoblastic. So some seeds, not only all the seeds, they are having the negative photoblastic seeds. So negative photoblastic seeds means like onion or lily, the flowering plant, or amaranthus. If we expose that type of seeds to light, during that time it won't germinate. So that case, some not need the light. But non-photoblastic means because it is whether light available or not. So this is not affected by the light. So that case, irrespective of the presence or the absence of light, this type of seed is having the ability to germinate. But the light sensitive seeds, that means the light is needed for the germination of the seeds. In that type of seeds, red region of the visible spectrum, that is very important to promote the germination. Because normally we know red region and far red region we are able to see in the visible spectrum of the, if we able to have in light, we have the visible spectrum as well as far red region also we are having. So here the red region of the visible spectrum, that is very important for the germination, especially in light sensitive seeds. The far red region, because it is immediately after the visible region, so near to the visible region. So it is having the reverse metabolic, reverse mechanism to the red light. If the red light promote, the far red light reduce the germination. So red light promote the germination, then far red light induce the dormancy. Like that, it is having the reverse mechanism in the especially light sensitive seeds. Then the other step we have to look into, I already told you, endosperm, cotyledon, these are present in the seed. So during the germination process, this endosperm and cotyledon, they are having the food reserve. Depending on the type of seed, it may have more carbohydrate or more protein or more lipid content. Example, if we take the cereal, it is having more carbohydrate reserve. But if we take the pulses, it is having more protein reserve. Similarly, if we take the oil crops like gingerly, it is having more lipids. So in that case, the mobilization of the reserves that can, depending on the which type of storage we are having. So if you want to promote the germination, whether it is starch or the protein or fat or lipid, that should be digested. That is in the complex compound that should be break down and bringing into the simple compound like sugars. Then only the metabolic, because energy needed for the germination will be obtained, and it promote the germination. So the food reserves that is available in the complex form like starch, carbohydrate, starch and carbohydrate, or protein, or the lipid or fat, that should be digested and converted into simple form like sugars. So I already told these things because if it is having the food reserve, especially in the sperm or cotyledon, that should be digested. Even in monocot, it is having the aileron layer also. In aileron layer, what is happening, the hydrolyzing enzymes are there. So that can break down the complex compound in the simple. So we are having the amylase and protease because protein can break down into amino acids, and amylase can break down the carbohydrate into sugars. So due to this, the metabolic activity is happening on due to the presence of enzymes. This activity of the hydrolytic enzymes will be promoted by the presence of gibberellic acid. So that can initiate the hydrolysis of the enzymes. Then the complex compound can be broken down into simple compounds. So due to this activity, the presence of hormone, the gibberellin, that can promote the germination, in which way it is initiating the activity of the hydrolyzing enzymes. So the amylase and protease that will start their activity. Due to that, because for the translocation of the assimilates, we normally know it should be in the simple sugar. So then it can translocate it. So after complex compound breakdown into simple compounds, it can translocate it to the whenever needed embryo part and whenever energy needed. The translocation of the food reserves happening. So due to this, the embryo is in a position to push out the root first, and it able to produce the shoot second. So metabolic activity started very actively. So cell division, cell enlargement take place. Due to that, it is able to germinate. So that is the thing we have to look into the seed germination. So first the water is absorbed by the seeds. Then the respiration is happening in the seeds to obtain the energy, because the energy is needed to promote the metabolic activity. Parallelly, the enzymes that is available in the aileron layer, that is helping to break down the complex compound present in the endosperm or cotyledon, and break down the complex compound into simple compounds that is able to translocate it to the embryo. Then the parts, we are having the plumule as well as the radicle in the embryo that able to push out because already seed coat also softened. So then rupture the seed coat or break the seed coat and able to push out the root first, then the shoot. In that way, germination is happening. Then we will look into what are the factors affecting the seed germination. Under that, mainly we have to look into the external factor as well as the internal factors. The important external factor, water, suitable temperature, oxygen, and some cases, light or darkness. Because the seeds that is need the light, so we are saying that positive photoblastic, that type of seeds, it need the light. In some seeds showing the negative photoblastic, so that won't need the light. So that need the dark. So under the external factors, mainly we have to look about the water because this is needed for the imbibition activity of the seeds. Then temperature, why it is important? Because the enzymatic, hydrolytic enzymatic activities happening during the germination. So for the embryo hydrolytic enzymatic activity, the temperature is very important because low and high temperature that can affect the enzyme. So the suitable temperature in that case, it is influence the germination. Then oxygen. So oxygen is very important. Why it is oxygen is very important? For the respiration, because that is the one step happening in during the germination process. So oxygen is needed to promote the respiration and produce the energy. So these are the external factors we have to look into. Under the internal factors, dormancy period, then viability of the seed, and thickness of the seed pod. This can influence the germination. Then under the external factor, first if you look into the water, and if you take the mature dry seeds, so it's need the large amount of water to absorb and start their cellular metabolism or resume their growth. So dormant seeds, if the water is available, it's dehydrated because initially I told you, so 6 to 15% of water is available in the dry seed. So we can even bring down the moisture content to 9 to 13. That is common. So while absorbing the water, the active cells, so that is require nearly 75 to 95% of water for their metabolism. So if we keep the moisture content of the seeds to 6 to 15, that is not applicable for the metabolic activity. So that case, it won't germinate. But if you want to promote the germination, water should go inside the seeds and water level inside the seed should reach to nearly 75 to 95%. So then the metabolic activities that can go inside, carry out inside the seeds, then it can promote the germination. So the water uptake by the seeds, we are calling that as imbibition, that we already studied in the stage of the germination. So that causes the seeds to increase in the size. The swelling is happening and seed coat also softened. So then it is able to easily break. So rupture of the seed coat possible. That is the thing. If you want to promote the germination, the first water has to go inside. So water is very important. That is I already mentioned. Then the temperature. Temperature is especially important for what purpose? Because during the germination, hydrolytic enzyme activity is happening. So for the enzyme activity, the appropriate temperature is very important. If the temperature is too low, the enzyme activity is slowed down. If the temperature is too high, that also affect the enzymatic activity, because the degradation of the enzyme will happen if the temperature is high. So the optimum temperature is very important to promote the germination, that is 25 to 30 degrees. If the temperature is below 0 and above 45, it stops the germination process. The enzymatic activity will be affected. Then oxygen. So the oxygen, because one step in the germination process we are having is the respiration. It is very important for the respiration and release the energy that is needed for the growth, because cell division, cell enlargement should be happen. Then only the growth will happen, because in growth we different phases we studied cell division, cell enlargement and maturation. So if we want to obtain the growth, cell division, cell enlargement should happen. So in that case, the energy is needed. For providing the energy, respiration should be happen. So to promote the respiration, oxygen is needed. So that's why I already told you, if the seed is adapted to the land, that case we have to avoid the waterlogged condition in that land, and we have to make the soil fine-tilled condition by doing the plowing and harrowing. It should provide the aeration and the ventilation, so the oxygen will available for the germination of the seeds. Then we will move to the internal factors, because in external factors, depending on the type of seed, the light also influence. So light sensitive seeds, we should definitely provide the light for the germination. Light insensitive seeds or the negative photoblastic seeds, we should avoid the availability of light. So depending on the type of seed, from the literature we can get that whether it is positive photoblastic or the negative photoblastic or non-photoblastic. So based on that, we can provide the light requirement. Then under the internal factor, the dormancy is the important mechanism. What is dormancy? Even if the seed is having the viable embryo, that viable embryo means that the embryo is able to germinate. Viable embryo, if you provide the suitable environment condition for the germination, that type of seeds won't germinate, because some mechanism seed is having after a certain period only it is in a position to germinate. So that type of mechanism we are calling that as dormancy. If the seed is having dormancy, even if you provide the suitable environmental condition for the germination, it won't germinate. But for the germination, the viability of the seed is very important. Viability means it is having the viable embryo that is able to produce the normal new plant or the seedling. The viability period of the seed that can vary with the crop to crop. Even some seeds have the viability for a few weeks. Some may have the viability for many years. Example, if it have the lotus, already we know the lotus flower. After a particular flowering, we able to get the black color around lotus seeds. But that lotus seeds is having the ability to survive as the viable nearly more than 1,000 years. So if it is in the soil for a long period, it is able to germinate. So if the seed need to germinate, it should have the viability. That is very important. So that case, under the internal factor, we should know about the dormancy. In addition to the dormancy, we should know about the viability. If the seed is not viable, it won't germinate. So the viability also the important factor, internal factor we have to consider. Otherwise, no point. Even if we have the seeds and keep it for a long time, if the seed is not viable, it won't germinate. Then thickness or the thinness of the seed coat. Depending on the thickness or the thinness of the seed coat, the germination rate of germination can vary. If the seed is having the thicker seed coat, it needs more time to germinate. But if the seed is having thinner seed coat, it will germinate quickly because it can easily break or rupture the seed coat and comes up. So that's why we are doing some seed treatments to soften the seed coat. Or we can say other way, we are doing some mechanism or methods to break the dormancy. Because if the seed coat is thick and it's not allowed to germinate, so that is other way it is promoting the dormancy. So if we want to promote the germination, we have to break the dormancy. To break the dormancy, we can use different methods. We can do the scarification. Scarification means by using the sandpaper or the needle or any sand, or we can make the seed coat that is little thinner. So that case we are doing, even that scarification can be done physically, that is by using sandpaper or sand or needle. But chemically also possible by treating with the diluted acids or the even warm water if we keep it. So that is possible. So scarification means the making the seed pod thin or the able to promote the germination. Then stratification also we are doing. So the substrates, low temperature treatment is needed to promote the germination. That process we are calling that as stratification. Even because the dormancy that can be caused by the next lectures we will study about the dormancy. So at that case we will look into these things very deeply. So the dormancy, so due to the seed coat or the embryo also some have some inhibitors that can cause the dormancy. So soaking like that we can do. So the next lecture we have to look into about what is dormancy. In which way we can break the dormancy. So we have to look into. So the thickness or the thinness of the seed coat also influence the germination. So I think that's all about these things. So in germination means this is the process happening in the seed from the seed to getting the new plant. That case, the 5 stages in the germination: imbibition of the seeds, respiration of the seed, and also light that can influence based on the type of seeds, the light requirement also there. Then mobilization of the reserves also needed. After the absorption of the water, the metabolic activity promoted by hydrolytic enzymes that is present in the algal layer. The breakdown of the complex compound into simple and translocation. Then it reaches the embryo. The embryo is having the promole and the radicle, so it is able to consult. The cell division, cell enlargement happens. Then the factors influence the germination. External factor, under that mainly the oxygen and also water. In addition to that, temperature we are considering, because temperature is influencing to control the enzymes. If the temperature is too much or too low, it will affect the enzymatic activity. Enzymatic activity is very important to breakdown of the complex compound to simple compound. Then oxygen already I mentioned. Then internal factor, seed dormancy, seed viability, and the thickness of the seed. So that's all about the germination. Then we will move to the next one, seed dormancy. Seed dormancy. So, if you look into the seed dormancy, I already told you. If you provide the suitable or the favorable environmental condition for the germination, viable seed is not showing the germination. So temporarily it suppresses the germination. So that is, we are calling that as seed dormancy. So the seed dormancy, even some seeds, after harvesting also, it needs some time for their maturity. So that is, we can call that as after ripening process. So different species or different crops having the different dormant period. The length of dormancy that is vary with species to species depending on the plant anatomy and the physiology. The seed dormancy, I already told you, it is the state we are able to observe in the seeds that prevent from the germination even if we provide the suitable, favorable environmental conditions. But that dormant seeds should be viable, that is alive. But metabolic activity of that seed is inactive state. Due to that, it is incapable of showing the germination even under the normal environmental condition. Because for the dormancy, the seed is viable, alive. But the metabolic activity that is happening in the plant is in the inactive state. But metabolic activity inside the seed should be activated if you want to promote the germination. So that is in the inactive stage, we are calling that as dormancy. So even if the metabolic activity is inactive, even if you provide the favorable environmental condition, it won't germinate. So to promote the germination, water, light, temperature is important. Even some mechanical restrictions also may be in the seeds, like embryo have some inhibitors or seed coat is preventing the germination. Some hormones present inside the seed also can prevent the germination. So the other way, it can promote the dormancy. So if the seed is not exposed to sufficient moisture or proper temperature or oxygen, even some species appropriate light, it won't germinate. In dormancy, there are different types of seed dormancy also there. That dormancy can be induced by some inhibitory factors that is present in the embryo, or some case seed coat also may have some inhibitory substance, or the thickness of the seed coat also can be influenced. So if you want to promote the germination, what should be the requirement? The seed should be non-dormant state. If the seed is in non-dormant state, then only it is able to germinate. So if the seed is in dormant state, that means some seeds need after ripening process or some treatments. This is the treatment we are giving to break the dormancy. It's a temperature treatment or the light treatment or some chemical treatment we can provide. So the dormant seeds, then it can be bring down to non-dormant seeds. Then it can show the germination. So if you look into the seed, so the after pollination and successful fertilization, seed is formed. Seed is formed after the maturity. So the mature ovule turn to seed. So this seed should germinate. Before the germination, some even if you provide some favorable condition, the viable seed won't germinate due to some reasons. So that is the seed dormancy. Then after the germination, it is in a position to give the show the normal plant growth and reach the maturity. So these are the process happening during the germination, because this is the seed monocot and this is the seed of dicot. So if you look into the germination, so I already told you. So in monocot, the cotyledon is below the soil, only the coleoptile and the epicotyle, the stem portion is coming up. But in dicots, the cotyledon is coming up. So due to that, it is called as epigeal germination. This is called as hypogeal germination. So if you look into the steps that is in dormancy, so from the dormancy, how germination is happening. So here dormancy is embedded the water. So hydration, so it's absorbing the water. The physical metabolic activity, even some cases happening, it is helped to break the dormancy, because some seeds, to break the dormancy, we are put it in the water for soaking. It will help to leach out the inhibitors present in the soil. So in that case, the dormancy can be broken by temperature or light or some physical reason. So this case helped to break the dormancy, and finally it promotes the germination. So that is the termination of dormancy finally happened, because even during the dormancy breaking mechanism. So the presence of abscisic acid, that amount can be decreased, because abscisic acid that can prevent the germination. So it promotes the dormancy. So due to the dormancy breaking mechanism, the abscisic acid amount can be decreased. And we already know the presence of gibberellic acid that is promoting the germination. So promoting the hydrolytic activity of the enzymes. So in that case, the gibberellic acid amount increases. This increases the germination. So this structural change happen inside the seeds even during the dormancy breaking mechanism. Finally, termination of the dormancy happen. Then seeds in a position to germinate. So sometime we will think about why we should have the dormancy, because it is, but if you want to store the seeds for a quite long period, the presence of dormancy is beneficial. And that should ensure the viability of the seed, survival of, because if seed is having the dormancy, it ensures the survival of the species. So in that case, the dormancy is needed. Because viviparous, that means some plants that is attached with the parent plant, or that is in a position to germinate. So a plant reproducing from the buds which form plantlets while it is still attached with the parent plant, or from the seed which is in a position to germinate even within the flower. So to inhibit that type of nature, the dormancy is needed. So some advantages if the seed is having dormancy, because even the seed is attached with the parent, it is germinate, so that is the problem. So that case, that type of plants we are calling viviparous plant. So that type of nature we should avoid. So the presence of dormancy is beneficial. Even in temperate countries, the presence of seed dormancy is very important, because to spend their time, especially during the cold, because that can cause the injuries to the vegetative and reproductive period during the winter time. If the plants are having with the leaves and the grass, so that will causing the injuries. So due to that, even temperate countries be able to see the 4 seasons. Autumn, the plants, they are shedding all the leaves. Then the winter starts, so we only be able to see the stem, leaves and all the things. So that is in the dormant period. Then we will get the spring, summer. During the spring, little by little, dormant buds and all the things started to grow. And during the summertime, we able to see the nice flowering and fruiting in the plant. So the temperate zone, the presence of dormancy is very needed. Even in tropical region, even if the water stress condition is there, so the dormancy of the seed is possible. So depending on the condition, the seed is adapting. So even due to the seed adaptation, if the rain comes, then it is able to germinate even in the tropical region. So even if we look about the disadvantage of seed dormancy, because it won't give the germination, but maintaining the plant population is difficult. But if you want to do some seed testing process, the dormancy also can influence to check for the germination and all the things. So here we have to look into what are the reasons maybe for the dormancy. So the dormancy may be due to the presence of light or temperature or period of after ripening or the presence of germination inhibitors, immaturity of the seed embryo, hard seed pod, impermeability to water or oxygen or mechanical resistance. These may be cause for the dormancy. So today we started to study about the dormancy. This is the mechanism. The seeds are having some seeds to tolerate the unfair. Even if you provide the favorable environment, it won't germinate. It needs some time to germinate. So that is the resting period is needed. So it is dormancy, the presence of dormancy is having advantage as well as disadvantages. Because whenever needed, if the seed is having dormancy, we can't get the seedling. But it is ensures the survival of the seed because the dormant seed also viable. So we can keep the seeds for a long time if the seed is having the dormancy. But based on our need, we are unable to get it. Seedling. That is a disadvantage also. So due to that, there are several mechanisms available we can do to break the dormancy. There are several reasons for the dormancy also. Sometimes the presence of germination inhibitors in the embryo, hard seed coat, or some impermeability to water, impermeability to oxygen, because to promote the germination, the water, oxygen all are needed. So it is, if it is prevented, so it won't germinate. So that is other way it is promoting the dormancy. So I will stop up to this today. Then in next class, I start with the dormancy and I will brief it again. Tomorrow, 7 to 8 also, we will have the lectures. Thank you.
Thank you, ma'am. Thank you, ma'am. Thank you.